Welcome back to All This Math. This is Professor Parker. Since you're here, go ahead and hit the like button. All right. If you're not already subscribed, go ahead and subscribe to the channel. Also, share this video with at least one other person. But you can wait till we're done. All right. And if you have any questions about anything, questions or comments about anything that I cover, right, momentarily, please put your questions or your comments in the comment section. All right. Now, what we're about to solve now, this is called a radical equation. Why is it called a radical equation? Is because one of the expressions is inside a radical sign. This sign that looks like a long division symbol is a radical sign, right? This means 3 times the square root of the quantity x plus 2 is equal to 12. And we want to know what the value of x is that makes this a true statement, right? This is part of problem solving, right? This is we're learning how to problem solve. When we're doing algebra, we're solving equations. I know people like to say, well, this is irrelevant. How's this going to help me in life? I'm never going to use this. Well, this is training you how to problem solve, right? And as a human being, as an adult, even as a teenager or a child, you will have problems. Now, some people in life have problem solving skills, so they're able to solve their problems. Some people in life do not have problem solving skills, so they're not able to solve their problems. So their problems grow, and get out of control, grow exponentially and exacerbate and all that, and spiral out of control. And then they end up going into all types of unhealthy behavior just to try to distract themselves from their problems. The best thing for you to do is develop problem solving skills. And what I'm trying to tell you, what a lot of people don't realize, what a lot of math teachers don't realize, what a lot of school principals don't realize, a lot of parents don't realize, is that math class is one of the best places to learn problem solving skills. But as soon as you fold and give up and say, oh, this ain't going to help me, this is worthless, I don't need to know this. As soon as you start saying that, you're never going to get the value out of it. You're never going to develop the problem solving skills, most likely. You might get lucky and still develop them in another way, but for most people, it don't work out like that. So at any rate, pay attention in math class. Pay attention to this video. All right. This is called a radical equation. But since we're talking about radical equations, I want to shout out the ancestor, the late Bob Moses, who co-authored this book, Radical Equations, which talks about mathematics and the civil rights movement. In his history of the civil rights movement, him being a member of SNCC, the Student Nonviolent Coordinating Committee, which we all should be familiar with. You know, people like Kwame Ture were in SNCC, Marion Barry, later became mayor of Washington, D.C. He was in SNCC. Marimba Ani, author of Urugu and a professor at Hunter College at one point in Manhattan, along with John Henrik Clarke, right? She was a member of SNCC. Gloria Richardson, Diane Nash. Who else was a member of SNCC? A lot of people. Albert Churchville, who was from Philadelphia, you know, from North Philly. You know, he was a member of SNCC. A lot of people was members of SNCC. Like I already mentioned, Kwame Ture, his roommate at Howard, Cleveland Sellers, he was also a member of SNCC, who was from South Carolina. All right. Cleveland Sellers, that is, was from South Carolina. But you know, Bob Moses writes about this in the book Radical Equations that I recommend to you, because he talks about mathematics and also the connection to civil rights work organizing and civil rights work mobilization. So check out Radical Equations. And this is a radical equation. All right, so let's get into it. Now, what do we do first? Well, first let's kind of look at our end goal and then work our way backwards. Our end goal is to isolate x by itself, because when we say solve for x, that's what we're doing. We're isolating x by itself. So we would know that x is equal to something on the other side of the equation. All right, some number on the other side of the equation. So that means that's the value of x that would make this a true statement. But our goal is to isolate x by itself. So it's a lot of stuff we got to get rid of. We got to get rid of this 3. We got to get rid of this radical sign, and we got to get rid of this plus 2. So it's 3 things we got to get rid of. My suggestion to you, whenever you're about to solve an equation, identify what you need to get rid of first, right? As a strategy, right? As a strategy, right? When you like kind of assessing the situation, assessing the problem, identify what it is you need to get rid of first. All right. So I need to get rid of this 3, this radical sign, and this plus 2. Now, one thing that you cannot do is you can't treat this radical sign like a set of parentheses, right? Even though it does encapsulate x plus 2, you can't treat it like a parentheses in that and then decide to distribute the 3 to everything inside the radical. You cannot do that. All right. Do not attempt to do that. You cannot multiply 3 by x and 3 by 2 and get the square root of 3x plus 6. Make sure you do not do that. All right. I want to point that out to you. That's wrong. We're not doing that. All right. But we do want to get rid of the 3. So we ask ourselves, what is the 3 doing? And this is one of the ways that algebra develops critical thinking ability, because by practicing algebra, what you're doing is you have to constantly ask yourself questions, right? in order to figure out in order to arrive or move toward the final answer, right? Which is what critical thinking does. Critical thinking forces you to develop the right question, because a lot of times we don't ask the right questions, right? In mathematics, you have to ask the right question. How do I get rid of this 3? And then you say, oh, well, what is the 3 doing? The 3 is being multiplied by this radical. So in an equation, whenever you want to get rid of something or eliminate something, right, from one side of an equation, you must do the opposite operation. So then you have to ask, well, what's the opposite of multiplication? The answer is division. So that means we're going to divide this 3 by 3, right? Or if we wanted to, we could multiply by 1/3, since that's equivalent. Multiplying by 1/3 is the same as dividing by 3. Just make sure you know that, right? I wouldn't do that, but I mean, if somebody was trying to be extra, they might multiply by 1/3, but it's cool, right? But then because it's an equation, we must be balanced. If I divide by 3 on the left side of the equation, I got to divide by 3 on the right side of the equation. All right. So now what happens over here? 3 divided by 3 is equal to 1. So now I have 1 times the square root of x plus 2. Now, if I got 1 times the square root of x plus 2, that's just the square root of x plus 2. That's all it is, right? So now I got the square root of x plus 2 is equal to, now 12 divided by 3 is not 9. Don't make that careless error. Don't do 12 minus 3 instead of 12 divided by 3. 12 divided by 3 is 4. You got to know your division facts. You got to know your division facts. If you know your multiplication facts, then your division facts will come naturally, because they're just the opposite. 3 times 4 is 12, so 12 divided by 3 is 4, right? So 12 divided by 3 is 4. Boom. Now we got rid of the 3. Now we got to get rid of this radical sign, right? Got to get rid of the radical. So when we're solving a radical equation, our 2 main steps are to isolate the radical and eliminate the radical. Isolate the radical and eliminate the radical. This essentially is what oftentimes oppressive regimes, totalitarian regimes, fascist regimes, what they'll do when you have people that are radical in the community, that are trying to organize the people, mobilize the people, and move to a liberation. They want to isolate the radicals and then eliminate the radicals. Same thing that happens when you're solving a radical equation. So the math be letting you know, right? The math lets you know the game plan, right? That we got to be prepared for. So square root of x plus 2 is equal to 4. How do you get rid of the radical sign? The opposite of taking the square root of something, ask yourself what the opposite of taking the square root of something is. The opposite of taking the square root is to square something, meaning raise it to the second power, meaning raise it to the second power. So it'll look like this. It'll look like, let me see, let's go to the next step. Boom, boom. X plus 2 is equal to 4. Right, parentheses and an exponent. And over here, same thing, parentheses and an exponent. Parentheses and an exponent, parentheses and an exponent, parentheses and an exponent, parentheses and an exponent. That's the opposite of taking the square root of something. That's the opposite of taking the square root of something. And then this radical will cancel with this exponent, leaving you with just x plus 2. Then over here, 4 squared is not 8. It's not 8. That's a careless error a lot of people make. It's not 8. 4 squared means 4 times 4. Again, a lot of math language, a lot of math terminology or nomenclature is just slang, right? We write 4 squared as like a form of slang, even if somebody don't want to admit that, even if somebody want to be all, so quote unquote sophisticated and not admit that. That's all it is, because all we doing is just, it's the same, it serves the same purpose that using slang and vernacular serves. It's a quicker, more efficient way to express an idea and communicate a thought, right? So 4 squared is, the long way to say that is 4 times 4. The long way to write that will be 4 times 4, but we don't want to write 4 times 4. So we write 4 to the second power, right? It's like slang. If you understand the slang, you're going to be all right. So 4 squared is 16. Now we got x plus 2 equals 16. Now this is like a one-step equation that somebody would get introduced to in a pre-algebra class. So we started out with all this, and now we down to this. So what happens is, in each successive step, in each line, like first line, like down in New Orleans, you know what I'm saying, with the parades and all that, right? This is our second line, right? And we got the third line and fourth line. The fourth line, we got a simple equation. X plus 2 is equal to 16. So now we're trying to isolate the x. Well, we got to get rid of this plus 2. Plus 2, what's the opposite of plus 2? Minus 2. So we always, again, we're developing our critical thinking skills by asking ourselves, what are we trying to get rid of? What operation is that thing we're trying to get rid of involved in? And what's the opposite operation? Those 3 questions we ask constantly. We did the same thing with the 3. What am I trying to get rid of? This 3. What is 3 doing right now? It's being multiplied by the radical. What's the opposite of multiplication? Division. Ask yourself those 3 questions every time. What am I trying to get rid of? What is that thing doing? And what's the opposite operation? All right. So then we're going to do minus 2 on the left and -2 on the right because we got to stay balanced. Got to stay balanced. What's 16 take away 2? Make sure you don't forget your subtraction facts. 16 take away 2 is 14. So x equals 14. Now, let's see if our answer is correct. Let's check our work. Let's do 3 times. No, let me switch up the color. Switch up the color so I can kind of differentiate. Purple, and let's do black. All right, so look, to check our work, right? We take the solution and we substitute it into the original equation, and we see if it gives us a true statement. We see if it gives us a true statement. If it does, then that means our answer is correct. If it does not, then our answer is wrong, and we need to go find our mistake. All right, so we check our work. We do 3 times the square root of 14 plus 2. Look what I did. I replaced the x with 14. I replaced the x with 14 because we think x equals 14 is equal to 12. I want to see if that's true. Let's do the math. What is 14 plus 2? 16. What is the square root of 16? 4. So then we got 3 times 4. The radical sign is gone. Ask yourself, is 3 times 4 equal to 12? Yes, it is. 12 equals 12. And there you have it. So 12 equals 12. So that means this is correct. That's proof. We check our work. And this is how you solve a radical equation. That's how you solve a radical equation. All right. So if you didn't already, go ahead and hit the like button. Subscribe if you haven't subscribed already. Share this video. Share this video. All right. Share this video. Somebody else needs to know how to do this. Right. They're going to see this in their algebra class. Maybe algebra 2, algebra 1, algebra 2, maybe. You know, could be in pre-calculus, like a pre-calc review, first quarter of the school year, something like that. Radical equations, solving radical equations. Anybody that's working on solving radical equations, this is a good video for them. All right. Yeah. If you got any questions about what I did or anything I said, drop it in the comments. Drop it in the comments. I'll check it out. If it's something you don't understand, I might make a follow-up video just based on your question. All right. So go get some practice with solving radical equations, and I will see you later.